The next topic is names and variables, which I'll use interchangeably in assignment statements. So, before I talk about why we would ever use variables or names, I want to talk about, I want to show you an example of what they are, because we gotta know what they are first before we understand why we would use them. So, I'm gonna run Python again, and let's say I want to do operations with 10 and 20 again, okay? And I want to do 10, 20, and then I want to do 10 times 10 plus 20 times 20 or something. Hold on, sorry. 20 times 20, and that's 500. Well, it's kind of annoying to repeatedly type 10 and 20 over and over again, okay? So, wouldn't it be nice if I had something that could remember what 10 was and remember what 20 was and just do it on that instead of retyping 10 and 20s all the time? So yeah, this is exactly what a variable is. So here I'm going to define a variable x to equal 10. I'm going to define another variable y to be 20. And what I can do now is I can just add by doing x plus y. I can multiply both of them together like the previous expression did and get 500. And this is overall just a lot more simple. Okay? So this is basically what a variable is. Now, variables can be assigned to anything. I can also assign another variable called name, let's say, to a string, like hello, and I can do stuff with that. I can also assign variables to each other. So here's an interesting question. After I execute this, so initially x was 10, right? And y was 20. After I do this, take a moment to think about what x and y are. Okay, I'll spoil the answer in 3, 2, 1. So x actually ends up being 20, okay? Because we basically took what y was and we copied it onto x. Okay, x took y's value. But we actually didn't do anything with y. Y is still actually 20. Okay, and to get y to change, we have to assign it to something else. So y equals 30, now y is 30. Okay, so this is an important idea in that we really go in computer science from right to left. We take what y is and we copy it onto x. Okay, I'll talk a little bit more about that later. So another cool thing we can do, let's say I have another variable, a equals 10 and b equals 20. How is it possible? Let's say I want a to be 20 and I want b to be 10. How can I do this? Okay, so there are a few ways to do this, but the most Pythonic way to do it is actually to just do something cool like this. I can just swap them like this, and now a is 20 and b is 10. Okay, so this, again, what we do is we ask, hey, what are b and a on the right, and then we copy them over to their respective a's and b's. And it's as simple as that. In some other programming languages, you might have to write 3 lines and introduce like a temporary variable to save one of the values and then copy them over. But in Python, it's really easy. You can just switch them like this. Okay? So that's the basics of assignment. So now you might ask, hey, why would I ever use variables? And actually, I'm going to go through an example of why. So let's take a look at that. So this is going to be an instructive example of why we'd ever use variables. Let's say I have a 0.34, and I'm going to introduce some syntax that you haven't seen, but that's okay. Just bear with me for a second. So let's say I have another variable, 6 and 8. Okay, so now, so these are 2 points, okay? How would I find the distance? Well, you guys know the Euclidean distance formula, so let's do that, okay? One thing I can do is I need the square root function, of course, and then I need to subtract 6 minus 3, right? And then multiply it with itself, 6 minus 3. And you can actually use a power function, which I'll show you in a second. And then I need to add this result. Oh, sorry, I need to multiply this by 8 minus 4, right? Actually, JK, sorry, confusing myself. Okay, I'm good, okay? So then multiply it, then add it to the result of the distance y squared. Okay. So yeah, let's do that. So I should get 5, right? Oops, square root is not defined. Okay, so this is an example of my first error. Okay, so You'll see errors a lot sometimes when you work with Python, and they usually give you nice descriptions of what's going on. So I need to import square root first. That's what caused this error. And so once I do that, I get 5. Okay? So I'm actually glad I got an error, because then we can talk about that a little. But anyway, I'll be talking about how to handle errors a lot later in the course. Right now we're doing pretty simple stuff. When you guys do a little more complex stuff, you'll be seeing some very interesting errors. And I'll talk about as much of them as I know of, and how to fix them. Usually Python gives you a good way to fix them, but sometimes it can be weird. But yeah, don't be discouraged if you get errors. Errors are not too bad in Python. Okay, so this is a pretty long statement, right? Like, yeah, I even confused myself while I was trying to write it. It's kind of annoying. So wouldn't it be a more compact way to do this? I mean, not necessarily compact, but easier to read and more organized, is we can define a variable distance x to be, so I can call it distance x squared, right? To be, so also another good thing is to be very descriptive with your variable names. So I can just actually, I promised to show you how to use a power function. So the power function takes the first argument as what you want to take to the power of. Sorry, that was very poorly worded, but I'll show you another example to make it clear. So I'm basically taking 6 minus 3, which is 3 to the power of 2. And so that defines that variable. And I'm going to define another variable, distance y squared, okay, to equal, what is it, 8 minus 4, okay? And then this makes that. And I know the distance, the total distance, is equal to square root of distance x squared, right? Distance x squared plus distance y squared. And now I find that the distance is 5. Okay? So this is a little more structured than this, because this is a kind of a jumbled mess, but this is a lot more structured. Someone who's reading your program will know exactly what's going on. Oh, and also, just to make clear what a power function does, so if I take 2 to the power of 5, I should get 32. If I take power of 3 to the power of 6, I should get 729. And yeah, cool. So that's basically one of the big reasons why we use variables. So it's a form of abstraction. So we basically take something that's very complex and we make it more simple. And we had that complex expression, of course, and with this use of variables, it made it a lot simpler to understand. And this is very important. And we'll be talking about abstraction a lot more when we talk about defining functions. But for right now, I just want to tell you that it's basically taking something that's complex and making it simple. A good example of that is like when you drive your car, you use your brake and accelerator. You never really think about how the brake works, all the inner mechanics of that. You just use the brake and you know that's going to slow down the car. So that's an example every day of how we use abstraction to take something that's a very complex process and make it more simple so that we have to worry about less things. And this is very important when you're programming, because you're going to be managing a lot of complex things a lot of times. And you want to make it as simple as possible. So the next thing also is that variables make things a lot cleaner. And we saw that in that example, in that once we had a value for distance x squared, distance y squared, it was a lot easier to kind of reason about what we needed to do. Whereas even in the previous example where we just jumbled everything together, I confused myself. And a lot of times when you use a lot of numbers together, it just gets very confusing. So it's just easier to define variables and make things easier for yourself, in my opinion. And a lot of other programmers would agree, I think. So the last bullet I have here is that it makes it easier to adapt to change. And we haven't really talked about how this works, but I'll show you in other examples later. But basically, one thing as a programmer that you're always going to do is you need to write programs that are going to be adaptive to change. Okay, what does that mean? So think about Google. Think about how many requests they get for features or products that they want. So whatever they're building, they're always going to be constantly making it better, optimizing it, making it efficient, things like that. So they're always going to be changing their code, and if they've coded in such a way that it's hard to change, it's going to be a lot more work to change it. So make sure you always code to change and code with the idea that it's going to change later. So just a we'll talk a lot more about that later, but just want to introduce the idea. Okay? And the last thing is, I briefly talked about this when I was going through the demo, but when you execute assignment statements, evaluation is from right to left. And this is super important. So in this example, let's say we have x, right? The first thing we do is we evaluate all expressions on the right of the equals, okay? So we have some primitive expressions. So we're going to multiply 20 by 2, and we're going to get 40, and then we're going to add it to 10, and we're going to get 50. And our value of x is then going to be 50, because we're then, after we've evaluated everything to the right, we're going to bind the name/variable on the left to whatever's on the right, the resulting value we got on the right. So that's how assignment statements work. And this will be a lot more clear when we talk about environment diagrams in the next video. And with that, I'm done. So thanks for watching. Let me know if you have any questions. I'll put the link to the setup stuff in the description. Again, feel free to ask any questions. I'll try to answer them as fast as I can. Thanks for watching. See you next time.